Let's start the recording. Okay, I think we start the record. Okay, we're starting. Welcome everyone. And my name is Yusuf. Probably most of you know me, and I'm just doing this because it will be a record. So maybe someone don't know me. I'm a software engineer in the settlements team. And you can reach me on the Slack and from these emails. This is a work email and my personal email. Okay, today I will talk about graceful shutdowns and implementations in Go. Okay, let's start with the questions. We have three main questions, and this is the first one. What is a graceful shutdown? Basically, in the hardware level, graceful shutdown can be explained like this. When you press a power button on your computer's hardware BIOS sends a signal to the operating system that inform operating system about the like shutdown situation and says like, let's close these files, let's save the files and close the computer. But you can press the power button for 5 or 10 seconds to force the shutdown, and that may cause a data loss. And the same logic actually works in the software state. Like if you close your application, kill your application before saving state or doing cleanup, you can encounter with some problems like unclosed files or not saved user data, and especially in a like industries, in a domains like ours, in the financial domains, it's kind of too important because you are working with money, and this important to like shut down things gracefully. Okay, for now we know what is graceful shutdown, and let's look at how we can do graceful shutdown. And for this, we have two questions. We need cancellation for this. And basically, cancellation is help you for shut down your code or your program. Like if your critical part of your process is failed, you want to stop other tasks too. Because if you don't inform other tasks about your situation in the service level, maybe you can cause the situation like forcefully killed, and we don't want something like this. And for doing this, we have a really cool package called Context in Golang. And I think Mikael did a lightning talk in the past about the context package. I will link it to my talk after after the talk, and you can watch it. And yeah, in the most case, when you are working with microservices, Kubernetes sends you signals to cancel and finish all of your jobs in your service. So that's the important thing, to catch these signals and finish your application. While we are talking about signals, let's look at what is operating system signals. All signals are basically interface that the interfaces used by the operating systems, mostly the Unix ideology, like the Linux and Windows supports, if I'm not remember wrong. And they are important because like operating system talks to your program with this interface. And in Golang, you have a great package for this. Is the OS signals is in the standard Go libraries. And okay, let's move on. And I will explain context a little bit more. And basically, in the let's think about a situation like this. You are a basic Twitter user and you want to see your followers. you will click the followers button, and the Twitter does this part. Request is sent to Twitter. Twitter's service takes this request and does a DB request for this data. And in the perfect scenario, all of this process finished without any problem, and you are show the followers to your user. But in some case, maybe user want to deny the request. Like maybe he has a bad internet connection and he don't want to wait for 10 seconds for see his followers. And in this case, if you don't stop the application process after the user deny his request, you will basically spend a lot of time with application process and database query. And we basically don't want this. In the base case, in the best practice, we want to stop our process after the user request denied. So we are using context for this, and I will explain it more in the future. We will see code examples for it. And let's look at the OS signals. We have some operating system signals in here. Actually there is a more signals than that, and but this three of them is more used, and you probably see them while working about operating system signals. We have a signal called signal terminate, we have a signal called signal kill, and we have a signal interrupt. Especially signal interrupt are used in the terminal, and if you press Ctrl+C in the terminal, you basically send signal interrupt to your program, your CLI program. Yeah, actually signal interrupt is mostly used in the CLI applications, like not mostly used, but they are important for CLI applications. SIG-term is basically a termination request. The operating system expects you to do, like if you get signal terminate, you will basically should close your process and close your application. And the signal kill kills the process in the kernel level. In some cases, it can't be catched by the program because it directly kills the program. So please don't use sig kill. That causes so much trouble. And there is another good meme about the signal term. If you use the signal term, your tax has a free time to talk their child. Okay, let's see code examples. I know listening in theoretical way is kind of boring, so let's see some code examples. Okay, I will use yes command for showing you operating system signals. Yes command basically just prints yeah on the terminal, and we can grep yes, and we can see the ID of this program in here, so we can send the operating system signals into this ID, process ID. So I will say kill an ID, and as you can see, it's terminated. The basic kill command sends sig-term message to process, but there is one more thing. You can send other signals with kill, like sigint. Oops, the wrong thing. Sorry. Yeah, as you can see, it's just interrupted. You can see the same behavior when you hit the Ctrl+C. it will print the control C, yeah, absolutely, and it will interrupt the comment. And one more thing, we can send signal kill to this process with like this, sig kill. Yeah, it's killed. It's terminated in the kernel level. And okay, as you can see, we can send signals between between the processes. So let's move on a little bit. Okay, our other use case is about Kubernetes and Docker. Oh, I forgot about the. Oh, sorry. I'm planning to show you the use cases for different repositories. Like in our Go Walking skeleton template, we added a function called listen for cancellation and add the context. It's basically just give us a two return. One is context, so we can use cancellation in our code, and one is done. So if you call this function, it basically terminates the program. And we are creating our context in line 16. And for the next, we are creating a channel for our signals, and these channels should be buffered, so we are giving a length of 1, and we are signing this channel to notify this all signals, which one is interrupt. We are listening for interrupts. We are ignoring the terminate part of the signals, and we are basically just looking for this signal to come, and if this signal come, we will exit. If the user force the like if user force this signal, like it does double control C, we are exiting forcefully without waiting the cancel function. For the next, we are using this in the payment system, and if you look at here, we are calling, we are listening for signal term, and if signal term comes, we are just stop the listeners, SQS listeners and Kafka listeners. So it's important because we don't want to like left open this listeners. It's important to close them. And for third example, we have an example from Kubernetes API server. And in here, as you can see, it does the same thing as our template. It will listen for shutdown signals, which in this case is, if I don't remember wrong, it's signal interrupt. And we are exiting in here. So basically our code examples like this. Okay, and let's keep up from here. Yep. The same logic runs when you work with Kubernetes or Docker. Kubernetes and Docker, if configured correctly, they will direct your OS signals into the containers in the services. You can see some containers in here. They probably don't listen the OS signals. Okay, for the next, we have a live example. I hope it works. And we have a really basic signal listener in here. We are listening for signal interrupts, for signal kill and signal term. And we are just printing them. And if this OS kill comes, we are just exiting. Okay, so I'm starting the listener function, and oops. Okay. It's RM, right? Yeah, it's RM. If I call RM function, what? Oh, sorry. Is it remove? It should be. Oops. Yeah. Oh, sorry, it's kill. Yeah. Okay. In here we use the docker kill, and our signal listener just exited. It's because we call kill signal when we use the docker kill, and kill signal kill the process in the kernel level. So when the kernel catch this signal, it's directly kill the program. It can't come this line. It's killed basically. And for the next, I think we can see different things. Yeah. As you can see, we can send different signals with kill command. In this example, I will send signal interrupt. And here, the interrupt printed in here. I put the 5-second sleep in here. I don't remember why I did, but it exists. Okay, so we can call signal term too. And if we call it, you can see the terminated part. And as you can see, our program won't close because we are just listening them and ignoring the signals. We are just printing them to the screen. And if we kill the signal kill, signal kill for RIP, it will terminate directly. Okay, and thanks for listening. Any questions or comments? I'm looking the chats for questions. Yeah, it's kind of awkward, Adam. Like, you are using too much harsh words. And I'm looking for it. Okay, thanks for listening and joining my lightning talk. Thanks, everyone.
Thank you so much.
Thank you so
Well
much.
done, Yusuf. It was
Thank
good.
you.
Nice one.
Well
Thank
done.
you. Great one. Bye.